Hi everyone. So today we're going to work on the other types of roots that we are going to explore, which are cube roots and odd even roots. So we want to be able to simplify some radicals when we're done, graph the cube root function, and evaluate cube root functions. So what we need to remember about cube roots is it's a number times itself 3 times. So we're looking for what number times itself 3 times is the radicand. Remember, the radicand is the number underneath the radical symbol. Okay. For example, 2 times 2 times 2, which is 8, right? 2 times 2 is 4, times 2 again is 8. So therefore the cube root of 8 is 2, because that number times itself 3 times gives us 8. Okay? And that's going to be our definition. The number c is the cube root of a if c cubed equals a. In symbols, we write the cube root of a to denote the cube root of a. So notice that we have an index, or this guy right here tells us that we're doing cube root. If there's no number there, we assume it's square root. So as we change roots, that number is going to change. So the first thing we want to do is look at the graph. I was actually got my little graph paper up again. It disappeared off my computer. All right, so we're going to make a little chart, and I'm going to pick numbers that are nice, perfect cubes to help us out. So here's our x. We're going to cube root x. So now the thing about cube roots is that if you remember, we can take the cube root of a negative number. Okay, so I'm going to use -8, -1, 0, 1, and 8. So the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. So that's what we're going to graph. And we're going to notice that we'll talk about domain and range in a minute. Okay, so let's see. Over -8 down -2. Over -1 down -1. 0, 1, and 8. Okay. So there's our graph. Now our domain of a cube root is going to be all real numbers, because we can put any number in and we're going to be able to get a solution. Now that solution may not be perfect. It could be decimals, things like that. And our range, if we look at our graph, is also all real numbers. Unlike the square root, which was positive reals and positive reals for our domain and range. Okay, so let's do some evaluating. Okay, so we have the cube root of y. We're going to indicate the function value, so we're going to put in 125. So we want to know, what is the cube root of 125? Now, if you're struggling with your cubes, okay. Sorry, my calculator is not available. Cube root of 125, so what number times itself 3 times gives you 125, and that's going to be 5. Okay, and then we got the cube root of -26 minus 1, which is the cube root of -27, -3, because -3 times -3 is positive 9. Positive 9 times -3 is -27. Okay, so again, we're going to do some more simplifying. Okay, so those are evaluating, so here's simplifying. Okay, so the cube root of -8, we're going to get -2. Again, -2 times -2 is positive 4, times -2 is -8. And then the cube root of y cubed, well, y times itself 3 times gives us y cubed, so -2y. Okay, the cube root of 1,000, well, that's 10t. Okay, all right. Now, if our roots, let's talk about the difference between having a odd root and an even root. Okay, So remember, odd roots would be like cube roots. Would be like cube roots, fifth roots. Even would be square roots and fourth roots, things like that. So we're going to focus on odds first. So every number has exactly one real root when n is odd. Odd roots of positive numbers are positive. Odd roots of negative numbers are negative. So unlike even roots, like square roots, you can have a negative underneath the radical sign. So keep that in mind. Okay, absolute value signs are not appropriate when finding odd roots. So if I'm doing cube roots or fifth roots, we don't need to worry about absolute value sign that we talked about the other day. All right, so let's do some simplifying. Okay, the fifth root of 32, so I believe it's 2. Okay, the fifth root of negative 32 is negative 2. The negative fifth root of 32 is negative 2. And the negative fifth root of negative 32 is going to be positive 2. Okay, that's because the fifth root of negative 32 is negative 2. We have a negative out in front, so that's going to give us positive 2. Okay, the seventh root of x to the seventh is x. And the ninth root of t minus 1 to the ninth is just t minus 1. Okay. All right, now, even positive real numbers have two nth roots when n is even, one positive, one negative. We talked about that the other day. Negative numbers do not have real nth roots. Okay, so when n is even, the notation nth root indicates the non-negative nth root. Thus, when we simplify nth roots, absolute value signs are often required. So when we have an even radical, square root, fourth roots, we're going to be using that absolute value sign because we can't guarantee that the number underneath is positive. Okay, so here's a little, I thought this was kind of a nice comparison. So if you're odd root, the cube root of 8 is 2, the cube root of negative 8 is negative 2, the cube root of x cubed is x. If you're an even root, the fourth root of 16 is 2, the fourth root of negative 16 doesn't exist, and the fourth root of x to the fourth is the absolute value of x because we can't guarantee that's a positive number for x. Okay, so I thought that was a really nice comparison comparing the two. Okay. All right, so simplify if possible and assume the variables can represent any real number. That means absolute values are going to come into play when we have an even root. Okay, so the fourth root of 81, what number times itself 4 times gives us 81? I believe that is 3. Okay, the opposite of the fourth. Okay, so we can do this because the negative sign is on the outside, not the inside. So the fourth root of 81 is 3, and then we're going to put a negative sign out in front of that. Fourth root of negative 81. So we say no solution because it's in the even root. Okay. Fourth root of 81 is 3. And the fourth root of x to the fourth is x, but I can't guarantee that's a positive number, so I'm going to put some absolute value signs around it. Okay. Sixth root of y plus 7 to the sixth. Remember, that means I'm trying to figure out what expression times itself 6 times gives us y to the 7th to the 6th. Well, that's y to the 7th. And I can't guarantee that's a positive number, so I'm going to put absolute value signs around that. All right, the sixth root of 64, I'm going to think it's 2. And again, I'm going to put absolute value signs around that x because I want to make sure it's positive. All right. Okay, so hopefully that clears up the difference between odd and even roots. Odds, you can have negatives underneath. Evens, you cannot. We don't need absolute value for odd. We do for even. Okay, so domain of odd and even roots. So what we need to remember is that even roots cannot have a negative radicand. Remember, that's the number underneath. Okay. And odd roots can. So odd roots can have both positive and negative. Okay, so which means that when I'm doing an even root like this one, I want to determine the domain, I have to be concerned about x cannot be negative, okay? This expression cannot be a negative number, which means I want it to be greater than 0. So we're going to do 7 minus 3x has to be greater than or equal to 0 for us to have the correct number underneath. So let's solve. We're going to subtract the 7. And then we're going to divide by negative 3, not forgetting to, please remember that when you divide by a negative with inequality signs, we have to flip the sign. So for this to maintain being positive underneath the radical, my values for x have to be less than or equal to 7/3. And that's going to be our domain. So we can have any real number. So we're going to say all real numbers. X has to be less than or equal to 7/3. Okay. All right, let's try this one. Square root can't be negative underneath. If that was cube root, we would just say all real numbers. Have a nice day. So here we're going to have, again, this guy has to be greater than or equal to 0 for us to be okay underneath the square root sign. So let's subtract the 3, divide by 2, so we get negative 3/2. So that's going to be our domain. It's going to be all real numbers. X has to be greater than or equal to negative 3/2. All right, so let's review for a moment. Let's go back to the beginning here and just make sure we're all on the same page. Okay, so cube roots, remember we're looking for a number times itself 3 times, gives us the radicand or the number underneath. We have our symbol. We found out it's a curve. And we're just, if I ask to graph it, I'm just going to pick some perfect cubes. Domain and range are all real numbers. Okay, we can evaluate. Okay, now simplifying. Okay, we're going to find the cube root. And again, the variable, it's what times itself 3 times gives us that exponent. Remember, we would think about like 3 of them. Okay. All right, so things that we have to be concerned about. Odds, our number underneath can be positive or negative. Evens, our number underneath has to be positive. Okay, and we're going to use absolute value signs for even roots, but not odd roots. Okay. And then for domain, again, domain for cube roots and odd roots is going to be all real numbers. It doesn't matter what's underneath. Even roots, we have to set it greater than or equal to 0 and then solve. All right, guys, let me know if you have any questions. Please stay safe out there, and I'll talk to you again real soon.